In a cubic centimeter of soil, you could have between 100,000 and 100 million microorganisms. We depend on them to break down our wastes, particularly sewage waste is probably the largest application of biotechnology, but we're just starting to, that's just the tip of the iceberg for what the natural world, the microbes out there can do for us. With the genetic revolution, people's ideas were to put some kind of laboratory engineered microorganism out into the environment. And other scientists have described this as taking a pampered pet poodle, the organism that's only grown in the laboratory, and dropping them out into the Amazon jungle. Because that's really what the outside environment is like. It's just teeming with millions of different varieties of microorganisms. And scientists have realized that there's a number of problems with that, and that actually we can accomplish a great deal more by working with the naturally occurring microorganisms that are there. It's this vast reservoir of biochemistry that we just need to learn how to encourage the appropriate microorganisms, and then we don't have to introduce some type of laboratory engineered microorganisms out into the environment. Just about any type of organic compound, compound that contains carbon-carbon bonds, can be broken down by microorganisms. And this includes things like oil, which was some of the earliest applications of bioremediation, using microbes to clean up the environment, to very exotic chemicals that never existed on this planet before humans came along, like PCBs and TCE. Some of the more recent applications of microbiology rely on their ability to actually carry out redox reactions with compounds. So there's microorganisms in the soil that actually breathe iron. The exact type of reaction that we carry out with oxygen when we breathe it in and we exhale CO2, they actually, and biochemically they're actually a related process, they'll actually breathe iron. There's other organisms that will breathe sulfur, that will carry out transformations of heavy metals and change them from being soluble to being insoluble. There's microorganisms that can form minerals and others that can break minerals down. So it's not just the organic chemistry and those types of chemicals that microorganisms can help us with. They can help us accelerate or retard processes that are going on in the environment that to some benefit. We do know a lot about microorganisms that cause disease, and that's what a lot of people think of. But the vast majority of microorganisms don't interact with people at all. Most of the organisms that grow in the subsurface, oxygen is actually a horrible toxin to them. And so they will simply die if they're brought up into contact with humans, up into the surface. The other thing that I'd like to say is that there's been a real shift away from using manipulated organisms to using naturally occurring organisms. These organisms are out there already. They're in the soil, they're in the subsurface, and they've been there for time immemorial. They have very little interaction with humans. I think the real negative outcomes are when we perturb a system without really thinking through or understanding what's going to happen.